All right, lesson 7.3.2 is composition of functions. Before we actually start on this, there's a couple of things I wanted to review with you. In the notation, if f of x equals 4x plus 3, all this represents is the f stands for the function of x. Okay, f really just names the function. So if I now want to find what is the function of 2, the f tells me this is the one I'm going to actually use. And the x actually gets replaced. So when I'm actually finding this answer, all I'm going to do is I'm going to replace the x so it becomes 4 times 2 plus 3. So 4 times 2 gives me 8. 8 plus 3 then gives me 11. So the answer to this is actually 11. Okay? We don't divide it by 2. We just find the actual plug it in and substitute it and find the answer. Okay? And I actually don't only have to plug in integers or numbers or even rational numbers. I can plug in variables. And all I'm going to do in this case is I'm actually going to change the 4 or the x to 3y this time. So it becomes 4 times 3y plus 3. Well, 4 times 3y is 12y. 12y plus 3. Okay? And I cannot simplify it any further. So that is actually my answer. Okay? 12y plus 3. Can actually do like a binomial. So I'm just going to replace the x with x plus 1. So when I do that, it becomes 4 times x plus 1 plus 3. And remember, only the x is the only thing that gets replaced with whatever's inside the parentheses here. So I distribute. 4 times x gives me 4x. 4 times 1 gives me 4. And then I add the 3. So my final answer is going to be, because I'm going to add like terms, 4x plus 7 as my final answer. Okay? All right. So let's take a look at another example. Okay, just like the one that we just previously did, sometimes you're actually going to have where they've actually got two functions. And so all we're going to do is I want you to find f of x plus 3. So just like the previous one we did, go ahead and pause the video and go and see if you can do this one on your own. Alright, so let's go ahead and take a look at this. Since this is, first of all, we got to match up the letters. So this is the function f. So we're going to match it up with the function f. So all we're going to do is, remember, we're going to replace this x with x plus 3. So we get 4. X plus 3 gets, or x gets changed to x plus 3 plus 3. So then our only other step then is to simplify this. So 4 times x gives us 4x. 4 times 3 gives us 12. And then it's plus 3. So then I get 4x, and 12 plus 3 gives me 15. Okay? All right. So now basically all we're going to do is we're going to take it one step farther. And if I wanted you to find the composition of the following function. Now, first of all, don't get too scared over the way this notation means, because this stands for, all I'm going to do is I'm going to actually take g of x and I'm replacing it with the x. So before we start off, let's do this. Always work your way inside. So g of x actually equals x minus 1. So I'm going to change this function to be f of, instead of writing g of x, because g of x is just x minus 1. So let's replace that to x minus 1. Okay? Now, now we're going to do exactly what we did before. So we're going to take the function f and we're going to replace the x with x minus 1. So it just turns into 4 times x minus 1, because we replaced the x. Okay, take out the x and we're putting in the x minus 1. Distribute, and I get 4x minus 4 as my final answer. Okay? All right, so let's take a look at another example. What if I did it actually backwards? Okay. Now one thing you're going to notice is just because before I had f of x, or g of x of f of x, now I'm going to actually do g of f of x. Okay? And just because I've written it the opposite way doesn't mean that it's actually going to result in the same answer. Because this time, remember, I'm working inside the parentheses, so this f of x is actually 4x. So I'm going to take g of 4x. Okay? So now I got to go back to my g function And everywhere I see an x, this time I'm going to replace it with 4x. So x turns to 4x minus 1. Okay? I can't simplify it any further, so that is my final answer. Okay? All right, let's look at an example of another example. Okay? This one's a U-try. So go ahead and pause the video and go ahead and try this one on your own and see if we can get the result. Okay? All right. So remember, all we're going to do, first of all, we need to start off by replacing this g of x in the parentheses. So the problem turns to f of x plus 4 is all it turns to. Okay? So then I go back to my f function, and I'm going to replace the x with x plus 4. So f of, oops, hold on a second. All right. So we're going to go with 10, because f of x is 10x. So remember, I'm replacing the x, which is x plus 4. So 10 times x plus 4. Okay, distribute, and I get 10x plus 40 as my final answer. Okay? All right. We can also do these with rational expressions. So remember, all we're going to do is first of all, the process is exactly the same. We're going to replace this g of x. So we're actually going to end up with f of x to the 3/4, because I'm replacing the g of x with this x to the 3/4. And then now, everywhere I see an x, I'm going to replace it with x to the 3/4. So I get 4, and then it's x gets changed to x to the 3/4, and don't forget, you still have to raise it to the 5th power. And when we raise simplifying it, when I raise a power to a power, I have to multiply. So it ends up being 4 to the x to the 15/4. Okay, that's my final answer. 3 times 5 is 15. Put a 1 under the 5. Okay. All right, last example. Now, I don't always have to do f of g of x or g of f of x. I could actually do f of x. Okay, and when I do this, first of all, remember, I'm taking the function f, and I'm going to replace this f of x with 4x to the 5th. Okay? And so everywhere I see an x, I'm actually going to replace it with 4x to the 5th. Let's say, okay, so we have, all right, so now all we're going to actually do is I need to go back to my f function, and I'm replacing the x, but I'm replacing it with the exact same thing, 4x to the 5th. So 4, x gets changed to 4x to the 5th power. And then don't forget, it's all raised to the 5th power. So I got 4 times 4 to the 5th power is actually going to give me 1,024. X to the 5th is going to give me x to the 25th power. Okay? Because remember, when I raise a power to a power, I'm actually going to multiply. Okay? And the only other last thing that I need to do is when I take, I need to simplify, and so I'm going to take 4 times 4,026 and get 4,096. X to the 25th. Okay? Okay. All right, that concludes lesson 6.3.